Hello everybody, welcome to another HD DWF arcade repair. This is the second of 4 Zaccaria Galaxia game boards that I got to be serviced. I can assure you that these boards never get repaired too easily. On this video I will skip most of the tests I usually do before powering it on. If you are interested, you can find all those tests in the previous repair videos, linked in the description. This PCB, like the previous one, shows some white deposits on the solder side. These are probably due to contact with water during the life of this board. However, this board was much easier to clean with the isopropyl alcohol. So I'm ready for the first power on. As I said, for details about the power supply and video connections, check the other videos linked in the description. All we have is a white screen with 2 grey bars right below the center. Having now a bit of experience with these Zaccaria boards, I can tell that the CPU is not executing any of the initialization code, if anything at all. As for any other CPU, we will then check the presence of a proper reset pulse, which is a high-level pulse for this S2650 CPU, and the presence of a good clock signal. And yes, the reset pulse looks fine at power on. On pin 38 we have a pulsing clock signal, so far so good. The next thing to check is usually the address bus buffers, if any. On this design, the addresses are buffered by a number of AND gates. I'm going to first check that all inputs and outputs show some activity. Here we have a stuck output. But that's because the gate's input looks like unconnected. It's U10B pin 10. Now U10B's pin 10 should go to pin 14 of the CPU, which is the address bus bit 0. However, pin 14 of the CPU shows a pulsing signal. This must be a bad socket. So I removed the CPU socket. And pin 14 shows continuity to U10B pin 10. That's good. Unfortunately, the CPU seems still stuck. All address bus inputs, however, look correct now. So I started checking continuity on all pins of all program ROMs. And sure enough, some sockets really have issues. Here is another bad one. These sockets have contacts only on their internal side. They are the worst ever made. So far I've found 6 of them that weren't making reliable contacts. They have been substituted with good sockets that have metallic spring contacts on both sides of the IC pins. They are the blue ones on this image. And this other blue one in position H8 too. This is also the EEPROM addressed right at the CPU reset. Unfortunately, we still get a white screen, but no grey bars anymore. The reason for the solid white screen could be because the CPU is unable to address any of the 2636 integrated circuits. So that's what I'll try to check now. This select line is definitely not toggling when I reset the CPU. I've then checked the connections of the pins of the three S2636 and I've decided it would be wise to get rid of those terrible sockets too. So more desoldering work and I've removed all of them. However, white screen again. The select signals of the three video ICs are produced by this 74LS139 and then inverted by 74LS04 gates to obtain the needed active high selects. So let's check these two ICs first. LS139 inputs look good. But this output looks bad. And yes, it's indeed bad. So that 74LS139 has been substituted with a spare one. But still we get a solid white screen. Anyway, now the LS139 outputs are good. I don't know. At this point, I thought maybe the problem is not really on the 2636, so I started investigating the color RAM circuit. These two 2102 1 kilobyte by 1 bit static RAMs contain the color information for almost all items displayed, excluding only the diving aliens and their bombs. The output bits of the two RAMs are sent to a 74LS74 in position 2A, so I'll first check this one. Outputs seem stuck. But this input is floating. The floating input I found is pin 12 of the 74LS74. This should be connected to pin 12 of the 2102 EC at 1B, so let's check it now. This is pin 13 untoggling. And indeed, 12 is just floating. This is not good. Let's also check the other 2102. And this one has a toggling output instead. So the 2102 at 1B was pulled and replaced with a non-good spare. Still white screen. However, now color RAM output works. And the LS74 output is toggling too. Now, since all three 2636 PVIs are correctly addressed, the explanation might be that one of them is bad. Since I have a working Galaxia PCB that I previously repaired, I thought to test them one by one in the working board. I've swapped the one in the middle. And look at this, that's bad. Testing another one now. 2 out of 3 are bad. So I needed to borrow 2 more 2636 from another PCB, of course after testing them. Finally, something changed. There are still problems though. At this point, I decided to change also the character ROM's sockets. and to avoid any surprise, also the remaining cold ROM sockets. I needed to wait for a new supply of 24 pins sockets though. Well, now we must look for more faults. One of the first things the game code does after initializing the three 2636 ICs is to clear the screen completely. We see instead what seems to be a random and flickering character pattern. I will first check the data signals on the two character RAMs at 1C and 2C, since I have already tested with the Data.io 29B program the two EPROMs containing the character and aliens shapes. I'm going to look at the RAM data pins by triggering the oscilloscope on the falling edge of the chip select signal, which is the top trace. The RAMs are selected only when the select signal is low, so we will look at the data signal shape only during this interval. Let's check first the RAM at 2C. This is always low. This slope is unusual. Another one always low. And this is bad, about 1 volt, not good. Let's check now 1C. 1 data low. Another one low. This one is high. And the last one shows both ones and zeros. So this 1 volt signal on one data pin during the select interval is surely not good, so I'm going to pull the 2114 static RAM in position 2C. I've then soldered a socket and installed a non-good 2114. Well, this is already better. Now, look at this character pattern. It is quite regular, and it seems always the same two characters repeating. For the moment, let's ignore the different colors that are stored in another RAM area. So I think that this pattern is a fault on the other 2114 in position 1C, and I'm going to pull also that one. Now, both character RAMs have been socketed and substituted. All we have now on the screen are these two bright dots, and this stays like this forever. Anyway, the CPU could clear all the screen now, or almost. The CPU gets stuck soon after clearing the screen. All the CPU working RAM area is contained into these two 2114 ICs in position 13F and 13G. Since already two 2114 of the same batch have been previously found bad, I'm quite sure that one or both these other two are also faulty. However, I couldn't really find any clue in the very short period that the CPU accesses these RAMs before getting stuck. And anyway, I had pulling ICs without a precise clue. To help me diagnose this board, I then decided to write some diagnostic code. Luckily, the manual for the Signetics 2650 CPU is available and contains all the information needed to learn how to program it. All links to documents and programs are, as always, in this video description. Then I needed a program to convert the assembler code into machine language data to be written into an EEPROM, and luckily this program also exists. And last but not least, I found this old disassembler program that allows me to disassemble the original game code, so I can look at what the original code does if needed. I've then made a quick socket adapter that allows me to use a 2816 EEPROM in place of the original 2708 EEPROM, so I don't need to erase a regular EEPROM each time I want to change my diagnostic code. I've first written down all information I could find on this board memory and I/O mappings. And then I've started writing some code to learn how to display any useful information on the screen. Let's try what happens with my first code. Well, clearly I need to learn better how this thing works. Okay, this will just iterate all video memory on all characters. It can be paused by pressing the fire button, so we can observe a static pattern and see if all characters and colors look the same. And it's just a start anyway. Anyway, the first thing I want to check on this board is whether or not the main CPU RAMs have issues. So, before I figure out exactly how to write things on the screen, I will be just using some output bits to indicate if the program finds errors or not. I'm going to use these two 74LS173 latches that the CPU can directly write to. These contain 4 bits each, so I'll write a 0 on the latch bit corresponding to a RAM bit giving an error, and a 1 otherwise. I'm testing first the video RAM that I know is good. And the first 4 bits are all 1s. All 1s, also the second 4 bits, so far so good. Let's check now the CPU RAM. One, toggling, untoggling, and 1. 1, toggling, toggling, toggling. Since the code indicated bit errors on both high and low 4 bits, then I've substituted both the 2114 at 13F and 13G. Then, by observing this image, which is a posed version of the character cycling code, we can see that not all characters have the same color, but my code writes all the same color information into the appropriate RAM segment. So the other 2102 color RAM I see must also be bad. And also this one was pulled and substituted with a good 2102 IC. So it is time to see what happens with the game ROM now. And look at this, we have the attract mode. However, there are still some issues. The ship is drifting away. Look at the relative position with its fire that changes. It seems like the ship's position is shifted together with the alien formation. And the alien's bombs appear in multiple locations at the same time. Let's look at the schematics again. The formation is shifted with a hardware adder that add a shift value to the character RAM addresses. This 74LS156 in position 4A produces a low signal that enables the adder circuitry when the central part of the screen is being drawn. In this manner, only the alien formation appears moving back and forth. So let's check the output of this IC. Well, the inputs seem okay, but all the outputs look stuck low. This cannot be okay. So I pulled that IC and installed a new replacement. And yes, the ship now doesn't drift anymore. Of course, the mirrored bombs are still there. The alien's bombs are displayed using yet another different RAM segment, called the shell RAM. It is made with two rather uncommon, even by 1980 standards, 2101 256 bytes by 4 bits static RAMs. At this point, I've decided to write a better diagnostic code that will test all the various RAM segments and display the results on screen. I first made all the development tests on the MEM emulator. Of course, on the emulator, every RAM segment tested good. Notice that the character set does not contain all the letters. I've also calculated and displayed the checksum of all ROMs to help me identify any potential ROM issue on a real machine. Now, on the real board, the diagnostic shows errors on the shell runs. It prints an O followed by the error address and a B followed by the error bits. A 1 in the error bits means a read error. A 0 means no errors. Notice that all the error bits displayed in hexadecimal after the letter B are always on the higher nibble, like E0, 10, 20 and so on. This means that so far the code found errors only on one RAM IC. According to the schematic, the higher bits are connected to the IC in position 2F. Of course, I didn't have any 2101 in my spare parts, so the replacement IC took a few weeks to arrive, but is finally installed in its socket now. So let's run the diagnostics again. And wow, it completed without errors. The attract mode shows no issues now. I'm going now to test all the game controls and coin inputs. And both coin inputs made the credits advance. I'll now start a 2-player game. And that worked fine. I've now also connected the sound PCB. The ship can be correctly moved to the right and to the left. And fire works too. I can finally say this board is fixed, and it surely was not an easy job. I've created a GitHub repository to share my diagnostic ROM, hoping that someone else can benefit from it and also contribute to it. A link to it is in this video description. So this is all for today. I hope you enjoyed this repair video and that you learned something. If you have any question, please use the comment section below. I hope you return to my channel in the future. Have a nice time and thank you for watching.